on iOS, stable and production ready. So yeah, thank you so much for joining what is essentially our little celebration that we have here, because the big thing the big milestone that we've reached recently, and that we, of course, as the team building Compose Multiplatform, are very, very excited about, is the fact that Compose Multiplatform now has added iOS as its latest stable target. And as a result of that, it means that Compose Multiplatform with version 1.8 is now fully production ready for your mobile application use case. Now, there's a couple of things that come with this release and that I also want to talk to you about. So today we're going to be spending a little bit of time getting an overall overview of the technology of Compose Multiplatform. We'll talk a little bit about some of the features that we specifically invested time into for the stable release. We'll also go hands-on with Compose Multiplatform, writing a little bit of code here and there, doing a couple of live demos, and also seeing what kind of new tooling, for example, we have live in action. We'll round it all out with an overview of the ecosystem and all of the wonderful libraries that the community is also building to support the Compose Multiplatform use cases. And of course, you'll get some hands-on instructions on how you can get started with the technology yourself. As a little disclaimer, of course, given this momentous occasion, we will be mainly focusing on iOS, but of course we are talking about a technology that's built for UI sharing, so a lot of the concepts that we'll be talking about today, they of course apply across multiple different platforms. Because that is the core idea of Compose Multiplatform, right? It's the idea of being able to write declarative UI using Kotlin DSLs, specifically using those that are already well established using the Jetpack Compose APIs and bringing them to multiple different platforms. Right? It's what Compose Multiplatform enables, to take what you already know from the Jetpack Compose world and bring it to new frontiers. And of course, one of the big parts that's very important here is that as you do this, you shouldn't have to compromise. You shouldn't have to compromise on your developer experience, but also your users shouldn't have to compromise on their user experience either. Your software should feel and behave exactly as they would expect. And of course, you want to keep access to the platform-specific features as well. As such, Compose Multiplatform is the natural conclusion of the Kotlin multi-platform story. With Kotlin multi-platform, you already had a stable technology for quite a while that allowed you to share business logic. With Compose Multiplatform, we're bringing you those same concepts just on the UI layer as well. And of course, the mobile use case is one of the ones that is the most popular, but I should definitely mention that we also have a desktop target that is stable as well, and a web target that is continuously evolving quite rapidly as well. So yeah, the core pitch of Compose Multiplatform is that they're well-known Jetpack Compose APIs that are extended for multi-platform. And Jetpack Compose actually has a pretty significant API surface. And of course, for building actual production-ready applications, you also need to have a whole bunch of different functionality, right? The good thing is that all of these concepts, whether they're layouts, the way that you manage resources or state, the way that you define animations, how you use material components, how you use safe zones, insets, cutouts, right? UI tests, and even things that really dive deeply into the architecture of your application. Things like how do you implement navigation, how do you work with lifecycle. All of this is also available in common code using Compose Multiplatform. And it's really about bringing you to a point where you're empowered to write this kind of code, right? These are very simple code snippets that if you have ever touched Jetpack Compose, I don't think should be very surprising, right? State management is the exact same way. The way that you write animations is exactly the same way. But now, that same skill set that you might already have, or that you might be looking into acquiring, you can now bring to multiple platforms without actually having to do anything new. And it's exactly this kind of powerful design decision that's already helped a whole bunch of teams implement their applications on top of Compose Multiplatform, even before it was stable. These folks have already built things, they've already deployed them out into production, and of course, a huge thank you goes out to them as well for helping us validate not just the use cases, but for giving us early reports and making sure that the stable version of Compose Multiplatform is really as good as it can be. And of course, if you're wondering whether maybe you have interacted with a Compose Multiplatform application before, this may be some spoilers from the keynotes, but of course, the Kotlin Conf app is also built entirely in Compose Multiplatform, so it can help you get a good feel for what that runs like on iOS. Now, there is one specific case study that I would also like to point out specifically, and that is Bilibili. Bilibili is one of China's largest video platforms, and they have actually adopted Compose Multiplatform for parts of their app. This is what Bilibili looks like. The instant messaging feature that is built inside the Bilibili application is built entirely on Compose Multiplatform. They have rolled this out into production, and there's already millions of users who are exposed to that Compose Multiplatform implementation. Now, granted, it's not their entire app. Their entire app is much larger than that, but they could actually do this. They were actually able to adopt Compose Multiplatform as a part of their application. Because just like with Kotlin in general, with Compose Multiplatform, it was also very important for us to allow you to adopt it on your own terms. Compose Multiplatform lives very happily alongside SwiftUI implementations or views or just plain old Jetpack Compose. We're providing you with all the interop layers that you need to embed Compose in SwiftUI or the other way around. And you, of course, have full backwards compatibility on Android, so anything you write in Compose Multiplatform, it's just Jetpack Compose when you run it on Android. But yeah, for us, it's pretty safe at this point that we can actually say Compose Multiplatform helps power the experience of millions of users, which is something that we're extremely, extremely excited about. Now, Compose Multiplatform on iOS being stable has a couple of different aspects to it. The most obvious one is that we now have a stable API and we have strict compatibility guarantees when it comes to talking about deprecations, for example. But there's also another aspect that's really important that we needed to do in order to really be proud to call Compose Multiplatform stable. And that's that it allows you to build shared UIs that really feel great on all platforms. And the key word here is really feel. It's about meeting your users' expectations on whatever platform they are, because oftentimes, depending on what operating system you run on, there's a certain physicality to the actual way that an application feels, the way that you move around it, the way that you navigate it, and so on. Showing this in slides is always a little abstract. So if we had a slightly higher budget, I would tell all of you to look under your seats and find a brand new iPhone. Unfortunately, that's not really an option, so instead we're just going to pop out here and we'll hop into the simulator and we'll just look at things together. However, if you do have an iPhone, you're more than welcome to actually tag along, because parts of this demo is going to show you an app that you can just download, which is the Kotlin Conf app. Again, the Kotlin Conf app is built entirely using Compose Multiplatform. And immediately when you use an iOS, you'll see that certain things, like for example, the way that things scroll and kind of skid along, that's the exact same behavior that you would expect from an iOS native application. This runs at the regular frame rates of your display, so on high refresh rate displays, your scrolling animations are smooth 120 frames per second, no problem. We've also invested a lot of time in making sure that all the springiness, all the overscroll animations are exactly right. If you do this in your own application, you don't actually need to do anything. This is just the default behavior that you get out of the box. Navigation is one of the other big points where iOS becomes quite opinionated. The classic example here is the back gestures. And just like with a regular application, the navigation happens using this typical parallax effect with a gentle fade on the background, and it sticks exactly to your finger, which is something that once you're really used to it, it is something that you immediately notice as feeling extremely well. Another part that's of course always involved is working with text, right? Text inputs are one of the classic things. So here, if I'm actually looking for, let me just go into the speakers tab so that I can pull up some familiar faces perhaps. If I type in Seb, we can see that we have a whole bunch of Sebs at Kotlin Conf. But we can also see that, for example, typical gestures well, I guess accepting the auto-correction, but also things like, for example, holding to get a magnifying glass that is provided by the system, double tapping to actually select a word, and getting the real handles that you would have in iOS native UIs as well. It's just something that comes out of the box. And again, for the stable release, we actually wanted to make sure that all of these interactions, they go all the way, including integrations that kind of are integrated further into the system. One of the examples that I have for this is drag and drop. So here's a couple of emoji components that just have a clipboard item attached to them. So what I can do is I can grab myself this apple, for example, and I can drag this into a drop zone, and it will tell me whatever data was originally associated with it. So for example, Compose for iOS, for Android, and for desktop. Within a single application, this isn't particularly impressive yet, but we are actually using the original iOS implementations for clipboards, so I can grab something from this element as well. I can navigate back into my home screen. I can continue dragging this apple out here, and then I'll actually see that I can drop it, for example, into the URL bar. So again, you can really build applications that feel native across different platforms. iOS is definitely one of them. Now, of course, like I mentioned, the other part that comes to feeling is you don't want anything being janky, which is why we're really excited that both on 60 Hz and 120 Hz displays, we're hitting those frame targets very well, and in our own scrolling benchmarks, we're on par with SwiftUI's own performance. And we're actually not stopping there either. We actually want to go further when it comes to performance. We're currently working on a new parallel rendering mode that's currently experimental, but essentially the idea is that rather than rendering your UI and doing all that drawing stuff on the main thread, we actually have a dedicated render thread, which means that your main thread is actually free to do other things like compute more complex layouts, do measuring, all these kind of things. You can currently enable it using the parallel rendering equals true flag in your Compose UI view controller, so you can just turn that on, and we would be more than excited to get your feedback about this stuff as well. Now, of course, one of the things that is extremely important as well when we talk about feeling is that your app feels good for all of your users. So we also did a lot of investment into accessibility out of the box with Compose Multiplatform. In general, on iOS, you automatically get functionality like VoiceOver. You get integrations with Assistive Touch that allow you to navigate through the individual UI elements, and you can also allow people to use full keyboard access with your applications without you having to do anything. Text inputs have been made specifically accessible also as part of the stable release, and we've also introduced customizable traversal semantics, which means that if you are building a lot of custom user interfaces where maybe the structure of your Compose nodes does not necessarily represent the physical location of composables on the screen, you can actually override this behavior, and you can specify how, for example, screen readers navigate through your application. So you have full control here. So overall, this allows you to build UIs that hopefully feel great across all different platforms and allows you to match the expectations that your users have when they open your app on iOS or on Android or anywhere else you deploy it. Now, we've been talking a lot about the experience of your users, but you are, of course, also developers, and you are important to us. So let's talk about your experience, and let's talk about what we're offering in terms of tooling for you. Because you might have noticed that Compose Multiplatform is built at JetBrains, and we are, after all, a tooling company. Like you saw this morning, there is a new plugin available for Kotlin Multiplatform that also brings the functionality for Compose Multiplatform specifically into your favorite IDEs, whether that is Android Studio or IntelliJ. You can simply download them from the marketplace in any of the latest versions. Once again, this seems like one of those subjects where talk is cheap, and we'd rather actually take a look at what's going on. So let's once again pop on over, this time into an IntelliJ version. Okay, so is that readable from the back? Can I get like a yes or a no? Yeah, I see a lot of thumbs up. Thank you very much. I appreciate the participation. Okay, so from the get-go, the way that you grab the plugin, of course, is just going to the marketplace and grabbing the multi-platform plugin. It's available in all of the latest versions. Once you've installed it, it allows you to actually start up your own project quite easily. You can just head on over to File, New Project, and then we have a Kotlin multi-platform wizard that allows you to turn on Share UI, and then you'll automatically have an application that uses Compose Multiplatform. And of course, you can configure different targets as you would want. Just to skip over the initial Gradle import, I already have a small project created here, but we can still go through the same way that we would if we had just created it. There's a couple of things that are worth talking about. Generally, when you first open a project, we run pre-flight checks for you. That's that little airplane over here on the side that actually makes sure that everything that you have is set up so that you can build and run your applications. Everything from your operating system over the Android SDK to Xcode, and it even does some checks to make sure that you can actually run the Gradle projects. If you are in the situation where any of these things are problematic, these pre-flight checks will also come with hints, or will just tell you which commands to run and allow you to run them with a single click to fix things, whether that's updating Xcode, adding simulator runtimes, and so on. From there, we can actually take a look at our typical code window. Of course, us as seasoned Jetpack Compose or generally Compose developers can look at this and probably intuit what that UI might look like. An easier way of doing this, of course, would be to open a preview like we have over here. Of course, we can't really see all that much just yet, since most of the things are hidden behind an animated visibility. But of course, if I wanted to make a change here, and I wanted to say, click me, please, I could do that. And of course, that would update just as nicely. I can also do things like I can jump into the animation preview here, and I can actually like scroll backwards and forwards, and I can see interactively my animation for my little code. Now, if you're someone who's an Android developer, you're like, okay, I've seen this stuff before. That's maybe not all that interesting. However, if we actually take a look, this is already an implementation that is built entirely platform independently. So if we take a look at this project structure here, we have our Compose app, which has multiple targets. We have an iOS target, we have an Android target, and then we have that shared implementation. And if we click our little scope here, we can see that we are actually currently editing code that is exactly running in, or that is exactly defined in this common source set. So anything I write here, like the change that I made with click me please, if I run this, for example, on Android, or if I run it using the iOS selector and I run it on my iPhone 16 Pro emulator, either one, I can run it, I can click it, and it behaves the exact way that I would expect it. So once again, here we have the application running on both platforms, all defined in just pure 100% Kotlin. Of course, this is just a very basic start, so we could maybe do something a tiny bit more interesting. Let's maybe bring up some images, something slightly more visual. I'll just get rid of what we have so far in here, and instead we'll start by grabbing ourselves some images to draw. I'll grab myself some codies, because of course, I mean, it is KotlinConf, so we'll just make sure we remember ourselves whatever our Cody service gives us back. This gives us a bunch of Cody data. I'll create a lazy vertical grid. Let's say 180. This seems pretty reasonable. We'll also make sure that it's the maximum size. That also seems good. All right, well, who knew that AI could be so helpful when you just want to skip ahead a little bit? And of course, we want to draw a couple of items. Actually, having them on a card seems pretty reasonable, so we'll auto-complete this part as well. Of course, we also want to specify a content description here, something like Cody. Okay, again, hopefully nothing too surprising here. If I run this, we can once again see this application, and we got a whole bunch of different Codys from different generations. One of them is 3D printed, which looks a little wacky, but we love it nonetheless. And even the original Cody as well here, with its slightly more astronaut-like design. Yeah, and of course, it kind of so natural that sometimes even I forget to talk about it, but once again, without me having to do any kind of adjustments, the overscroll behavior, it's exactly the one that you would expect on iOS. It feels natural, it feels good. Of course, again, I kind of just glanced over this, but yeah, we drew a couple of resources, and we drew them without really having to do much extra work. If we actually hop into our Cody's implementation here, we can see that on Compose Multiplatform, instead of the R class or the R object, we just have res, and then we can still have our drawables. For example, we have this happy Cody. And instead of living in a source set that is specific to Android, you just have this Compose resources directory. You have all your drawables in here. And of course, you can easily navigate back and forth between these as well. The actual entry point of our iOS application does still live in Swift. We can actually take a look here, check out our usages, and we can see that on iOS, the entire thing is wrapped as part of a main view controller. And that's actually the one that if we hop on over to the iOS application and its content view, you can tell that this is the exact same one here. So if your question is, how do I actually bring Compose Multiplatform into an existing iOS application? The answer is the same way that you would bring in any other UI view controller. It's exposed in a completely natural and a completely transparent manner. All right, great. That concludes our first little demo. We've seen a couple of things here, right? We've seen that we have wizards that allow you to get started quite smoothly and quite easily. We have seen that we have pre-flight checks that make sure that your entire setup actually works when you want to get started and can also help you in case things are broken. With previews, and even the more extended ones like the animation inspector, it's really easy to make changes to your Compose multi-platform UIs, even when you write it in a completely platform-independent manner. And of course, we could run, and luckily we didn't make any mistakes, so we didn't have to debug, but you can also debug your applications, even when they run on iOS, using the native debuggers that we have available. And resource integrations exist just as you would expect them to. But there's another very cool piece of technology that we've been working on, and that, of course, is hot reload. Once again, one of those things where slides will definitely not do it justice, so I'm just going to hop on over once again into another little project here. And this time, the project that we're going to be pulling up here is the Kotlin Conf app. The Kotlin Conf app is just like everything else, so you compose a multi-platform application here. It has one of the special points that this one does not just target Android and iOS, but we actually also have a web version that you can just check out in the browser using Kotlin multi-platform on WebAssembly with Compose Multiplatform for web. It also has a desktop target. So here we actually have a pretty big benefit, which means that we can hop in here, and again, with the newest tooling installed, I can right-click this little play window, and I'll get the second entry here, which has a nice, cute little flame next to it, which is run the execution or run the actual application with Compose hot reload. And if I start this, we can see that the application starts as normal, but there is something a little special about it. It comes with this nice little companion widget that seems to follow it wherever we drag the window. We can also click on that, and that actually gives us a little bit of insights into some of the Compose hot reload tooling. Well, what does that actually do? Well, let's hop on over to, for example, the speakers panel, and once again type in something like Seb. I'll try to make sure that I'm arranging myself in a way where where you can see everything. It's much easier when you have like 2 large monitors, but we'll make do. So the UI components that are responsible for rendering these specific elements here that we've navigated to, these are called speaker cards. So of course now we could make a couple of changes. For example, on this row, we could add a little bit of padding, right? We could just add like a padding of 20 dp. We could save this. We can see this orange bar appear, which indicates that Compose hot reload is working. The first time always takes a tiny bit longer, but once it has done it, it updates immediately. And of course, the main point here isn't that I can just quickly change some paddings. The real big benefit here is that all the state that you already have is also preserved, right? So gone are the days of like going back to the same screen, typing in the same thing, and then doing like a comparison. Instead, we're still on the speaker page. We're still searching for Seb, and things are just changing there, right? So now if we're saying like, hey, we really want to put those Sebs in the spotlight, we'll make the size of the modifiers actually a little bit bigger. Rerunning those, we can once again see that the images actually change. Right. And of course, I can just like undo this as well, and it will immediately, whoops, I can undo this as well, and undoing those changes rolls us back to exactly where we were beforehand. Now there's another quite interesting point about all of this. So let me just very briefly actually pop on over here and open up the Junie tool window, and just ask it something like, on the speaker overview page, use a 2-column grid instead of a list. And we'll fire this one off for a second here. And while Junie works, I want to talk about why I think this is actually such an interesting demo, because it illustrates why it's a huge benefit for Compose Multiplatform to not reinvent the wheel from scratch, but actually be built on top of APIs that are already well established. Because whatever AI assistant you might use, most likely they already understand how to write Jetpack Compose code, and by extension, they also know how to write Compose Multiplatform code, right? So here we can see that actually very quickly, Junie did the task that I asked it for. I can actually pause it here, and I can ask maybe a follow-up task like change each speaker card so that the image is above and the text and title below are centered. And we can let this continue working for a second. So yeah, whatever tooling you use, you can get very good AI assistance for Compose Multiplatform as well. Of course, here I am showing Junie because that's what we're building at JetBrains, and where we're also doing a whole bunch of things that are specific for Compose Multiplatform. We have more extensive demos about this at our booth, so if you are interested about what it can do, how you can just, for example, bring images in and have Junie implement those for you, or how it can automatically run tests for you, those are things that you can all check out at the booth, and we're of course more than excited to talk about it as well. Junie is probably going to be tinkering here for a while, but in general, as Junie continues, we can see the kind of changes that it makes, whether these are like small changes, just turning a fixed grid cell of 1 into multiple ones, or whether it's making some other edits, like realizing that it forgot an import and fixing these things. So it just kind of tinkers away. Perhaps we can check in on this in a little bit. Actually, never mind, we don't need to. Look at that, once again, without me doing any other changes, we just asked it to do it. I think that's worth an applause, right? Yes, and Junie also understood that it is indeed done, and once again, we're still on the page with all the Sebs on it. We've never lost any kind of state. All of that worked just as we wanted it to. Now, one of the points that's, of course, worth discussing about here, or that a critical mind might say, is, well, I'm a developer who develops an Android application and an iOS application, and now you've shown me a bunch of things that all work on the desktop target. So what can I get out of it, right? And I'll level with you. You're absolutely right. Currently, hot reload only works on the JVM target. But there's still an approach of how you can make use of it, and it's actually one that we also employ in the in the Kotlin multi-platform, in the Kotlin conf app. There we go. Which is we actually structure our application in a way where the UI components are their own separate module, and then we have a UI components gallery module that essentially has only the logic required to display elements from our UI toolkit. So if I run this one, it's not the entire application, it will just show us all of the components. But the good thing, of course, is that these are all interactive, so clicking them gives us the nice click indicators. We have a way to zoom in here as well and really see details. So if we're prototyping the way that, for example, Cody looks, or we have some sort of specific animations like these ones, we can immediately fine-tune them on the desktop target without ever having to actually implement the entire application on desktop as well, which is something that's quite powerful. So in general, hot reload, oh yes, and this window also really likes sticking on the top of all the other windows. There we go. So in general, hot reload is a great way for you to prototype faster, because you can just write UI code and you can see all the changes without restarting, and you keep all the state as well. Once again, when it comes to feeling, it's one of the things that's really good because it allows you to just do more iterations about how your UI actually feels when you interact with it. It is targeting the desktop JVM, and actually specifically it runs on the JetBrains runtime, which is a customized OpenJDK build that we maintain at JetBrains. It's also the thing that, by the way, powers all of the IntelliJ-based IDEs. So all of them run this specific runtime as well. This is also probably a good point to say that we actually saw another Compose Multiplatform application in our little demo here, because Juni itself and Juni's UI, that's also built in Compose Multiplatform, just with the desktop target. Yeah, there's a special thing under the hood called DCEVM that powers all of this. We're certainly not going to spend enough time on this, but I will give you a recommendation of where to go if you want to find out more about this. My point is that even if you are a mobile developer, if you're only targeting iOS and Android, by doing something like actually extracting your widget library and making that one completely platform independent, it is pretty easy for you to extend your application with a gallery module, with a gallery app that doesn't have to implement any of the perhaps complicated business logic that you have, but that still allows you to iterate and fine-tune on the interactions that you have. Compose Hot Reload is actually already automatically enabled when you create a new project using the project wizards inside of the IDE. For installation instructions on any other project, you can head over to the GitHub repository there. And of course, it was quite an interesting journey to actually create Compose Hot Reload. You can probably imagine it's not a particularly easy piece of software. So if you're interested in how all this works under the hood, I can very much recommend that you go to my colleague's talk, Seb Selmayer's talk, implementing Compose Hot Reload. That's happening today at 15:15 in auditorium 11+12. So, like we've seen, Compose Multiplatform, by its nature, by the way that its APIs are structured, works splendidly even when you're working with AI tooling. So really, we should probably amend this list of tooling things to also include Hot Reload and to include AI integrations. Okay, we've seen a whole bunch of UI building, a whole bunch of UI tinkering, but building a real cross-platform mobile application, of course, requires a little bit more. It's not just the UI, right? There's a whole bunch of things that come in here. You don't want to give up any of the platform capabilities, right? Because there's powerful SDKs across different platforms that you can use. You want to make sure that all the navigation principles that you might already be familiar with, you also want to bring into common code. Things like image loading and, of course, architecture components, doing things like dependency injection, and managing persistence of your app. Because, like I said beforehand, you don't want to give up any of that access to those iOS APIs and those Android APIs. And here, we're once again standing on the shoulders of giants. Kotlin Multiplatform is the technology to allow you to access all of those APIs from 100% Kotlin code if you so want to do it. So you implement them once, you provide a common implementation, and then you can just use it from common code. Once again, let's just see it in action. Let me hop on over once again to our little Kodi demo that we had in advance before here. And let's just say that, well, we'd like to bring in some functionality that's native. One of the classic examples that I think is always wonderfully visual is to bring in some sort of video player, for example, right? So we might grab ourselves a new column. We'll make sure that this one actually fills the maximum size. And we'll drop in a video player. We'll have to provide some sort of URL for this. I'm fairly certain that the Kodi service should provide me with a URL. It does not. Give me a second here. I do have it on a different branch, I believe. Yes. Here we go. So we're bringing this one into the video player URL. So we'll pass this one in here with our Kodi welcome, and we'll also specify a modifier, which in our case, I think this is a 16:9 video. So we'll just make sure it fills the max width and then have an aspect ratio of 16:9. So how would we actually implement this video player component, right? Because it clearly needs an implementation that's specific for Android and one that's specific for iOS. Well, let's actually take a look. If we click on this one, we can see that its definition is actually quite simple. It's just an expect function. Expect functions are a regular concept that you get from Kotlin multiplatform. It's essentially just a composable function, and you say, hey, there should be an implementation on Android, and there should be an implementation on iOS that gives us whatever we need. I don't want to spend too much time on the Android side of things, but we can briefly click in here. It's just an implementation that's based on ExoPlayer. So this one, I think, is not particularly special, but I can also hop into my iOS implementation, and here we haven't really written anything yet at all. So let's actually bridge ourselves into the world of iOS. And we do that by using a function like UI view controller that just allows us to specify a new UI view controller from iOS. There's a couple of functions we need to fill in here. The first one is the factory. Here we need to actually create a new player. So we'll just create this one. And you'll notice that I can just create any kind of objects that are part of the iOS SDKs, like AVKit, for example, right? I can just create an AV player from AV Foundation here. I can specify its URL, which in our case is indeed the NS URL, but I think it's just like this, so we'll just specify it as such. We'll also need to specify the actual controller for it, which AI is correctly suggesting here already. We'll need to link them up, and then we'll actually return them as part of the factory. And of course, to make sure that they're properly sized, we will also forward the modifier that we receive. That's just an overload question. Here we go. OK, so this is the entire implementation that we need to do video playback on iOS. Of course, seeing is believing. So let's run this application here. Give it just a second. And if I hadn't messed up the stacking, that's something that probably I should still get better at. Like, for example, not closing the column immediately after. Maybe Juni is going to take my job. Who knows? There we go. That looks a little bit better. And if I click on this one, we can see that it does indeed play the video. So yeah, you can clearly tell that with very little effort, you really have access to 100% of the APIs that are available across your different platforms. And on Android, Here we go, it's loading as well. Slightly more choppy, I'll blame the emulator. Right. So you really do have a full access to the entire suite of things. Whatever you can, I was going to say, whatever you can dream up, you can use. That's maybe a little intense, but whatever is actually available in the documentation or the SDK, like AV player layers, like things from MapKit. If you wanted to have maps that are customized in any specific way, you can just pull them in a way like this, and you only have to do that once, and then you're done. And of course, since this is all just Kotlin multi-platform code, this goes beyond the UI. If you want to schedule a local notification on iOS, you just do that using the regular notification center APIs that are available as part of the SDK that's just exposed to you in Kotlin. You don't ever have to write any adapters for this. That's all taken care of for you. And of course, a lot of components also come pre-commonized. You can pull in libraries like, for example, CAF, Compose Adaptive Look and Feel, that allows you to just call functions like we did with Video Player. Here you could, for example, do an alert dialog. And on Android, that one would show up as Material 3. On iOS, that one would show up as a native iOS dialog. Things like date pickers, all those slightly more complex parts. And of course, there are also other things that are always a key part of your application, right? Things like architecture components. The classic example is a view model. I don't think we need to talk too much about it because, once again, this is just the code that you would expect it to be. You get your wonderful view model scope, you can do things, you can work around with your flows and so on. And the actual view models that we have here, they follow the exact same contracts that you already know from Android, so you can just use them. Especially if you already have an application that's already existing and you want to add multi-platform to it. This just means that the actual path to multi-platform is not particularly difficult for you. You can take a lot of the logic that you've already built and just bring it along with you. Navigation is a similar story, and it is one that we have recently updated as well as part of Compose Multiplatform 1.8. It's now type safe, so you can specify your routes as objects that are serializable or data classes that are serializable, and you can use them to get the navigation arguments as well. We now also have support for deep linking, so you can have people be sent into your application, for example, from mobile Safari. And we also have adaptive navigation, including, of course, also the back gestures that we've seen so far already in the Kotlin Conf app. And overall, it comes with a pretty productive ecosystem as well. We have, as an image loading library, Coil, which is practically the de facto standard for loading images in the Jetpack Compose world, now also available in Compose Multiplatform. So that code can also just stay the same. It's very exciting for us, of course, and I'd also like to give a big shout out to everyone working on Coil. They very much deservedly also received a grant from the Kotlin Foundation to help actually bring that library to multi-platform in the first place. For dependency injection, you can already use Coin. They've been very diligent about also supporting Compose Multiplatform specifically, so they have extensions for example, multi-platform view models and the like that also work extremely well. And for those of you who are fans of Dagger, there's been a recent comment in the issue tracker regarding a KMP version of Dagger, which says that we've actually been working to support KMP, and it's now also officially on their roadmap, which is quite exciting. There's a whole bunch of persistence libraries, whether those SQLite, KStore, multi-platform settings, or data store that are already supported. But of course, one of the ones that is particularly worth shouting out is that Room is now also Kotlin multi-platform and is stable on Kotlin multi-platform as well. And all of this is pretty much part of a larger commitment from Google's side as well to support Kotlin multi-platform. And since we, with Compose multi-platform, when we build up our applications, we're just sitting on top of Kotlin multi-platform, you get to use all of that as well. It's a pretty large collection of Google libraries that are actually already available for the multi-platform use cases. One of the ones that is currently still upcoming is Navigation 3. This one was very recently announced, but Google is actually building it from the ground up in a way that makes it naturally ready for adoption with Compose Multiplatform. So stay tuned on that front. Now, of course, we also keep up with Jetpack Compose in general, so as new features come in, you also receive those as part of Compose Multiplatform just a tiny little bit later. We now have 3 targets that are stable and production ready. That's desktop, Android, and iOS, and web is going beta later this year, which is also one of the things that we're still pouring a whole lot of heart and soul into to make sure it becomes really, really good. So, to summarize, what do we get with Compose Multiplatform 1.8? You get shared UIs that feel great. You get to use established APIs for them. You can adopt it entirely on your terms, whether you're a large video streaming application or just starting your new side project. You get full access to platform capabilities without even having to leave Kotlin at any point, and you have a rich ecosystem that's all supported by solid tooling. So, if you agree with me that it is now time to build, then of course I would very much encourage you to start with KMP. You can do that by going to jb.gg/compose and find the instructions on how to actually get started. Compose does evolve with you, so we're very, very thankful for any kind of feedback that you're giving us. And now is actually a great time because the Compose Multiplatform team is taking a quick breath after this big release. But after that, we'll be doing a whole lot more planning. We, of course, want to evolve the framework so that it feels good for you as its users. So I do hope that you enjoy Compose Multiplatform, and I hope that you, of course, don't forget to vote using the Compose Multiplatform app. Thank you very much.